Translations, reflections, and rotations preserve. What does preserve mean? Stay the same. They preserve the side lengths. So your side lengths would stay the same and your angle measures. They preserve side lengths and angle measures. Preserve side lengths and angle measures. So translation means to do what with something? Just to slide it. So would the side lengths and the angle measures stay the same?
Yeah.
Yes. What does a reflection mean to do? To flip it. So again, these are going to stay the same. And then rotation is a turn, and that keeps things the same. Okay? All right. What does a dilation do? Makes it larger or smaller. Are the side lengths going to stay the same if you make something bigger or smaller? No. Will the angles change?
No.
Very good. The angles don't change. So it does preserve angle measures. So the angle measures will also stay the same on a dilation. Keeps the angle measures the same. The side lengths will change, but not the angle measures. Okay? All right. I know in Math 1, your teacher probably had things that they always said for domain and range. Domain is your input. It's what you start with. Domain is your input. What do you think range is going to be? Output. Okay? So domain is your input, range is your output. Does anybody remember from Math 1 what they said for domain and range? Okay, good. All right, so input and output. We'll stick with that. All right. Number 1, polygon ABCDE is a regular pentagon. The measure of each angle of an n-sided regular pentagon or regular polygon can be found using the formula 180 parentheses n minus 2 over n. Okay. What's a key word I should circle? What's something I should circle? All right, the formula, yes, that's something that's always important. I should circle that. What else? What else is important in that sentence?
Pentagon.
Caleb? Pentagon. Okay, pentagon. How many sides does a pentagon have? 5. What do you think you're going to put in for n? 5. Okay, so 180 parentheses 5 minus 2 over, what goes on the bottom? N. What is n though? What do we say n was? 5. Okay, n is how many sides it has. It had 5 sides. Okay. When you type that in your calculator, you need to do just the top. When you type it in your calculator, just the top. Got to be careful when you're putting in fractions. So 180 parentheses 5 minus 2. Put it in your calculator, and then I'm going to press enter and then divide by 5. That's the best way to do fractions. Type in the top, your numerator, and then hit enter, divide by 5. What do you get? 108. Got to be careful. Sometimes the calculator will work even if you don't do it, but that way always works if you put in the top first. All right, so I get 108. What answer has 108 in it? C. Let's read C though, just to make sure we understand what it's saying. Angle A prime, B prime, C prime will have a measure of 108 degrees because the angles of an image after a translation are congruent to the corresponding angles of the pre-image. Is that true? That was a lot going on. It said after a translation, what's going to be congruent still? The angles, okay? And that is true. All right. Number 2, write the domain and range for the following transformation. All right, what did we say domain was? The input, which in this case we have 2 shapes. Input is what you're starting with, all right? Input is what you're starting with. Which one are we starting with? The one on the left or the right? On the left, because it doesn't have the primes, okay? It doesn't have the primes. So this is our first one. And what we're going to do is just name the coordinates. That's all we have to do for the domain, name the coordinates. So A is at -5, 1. A is at -5, 1. Where is B at? Good. And C?
0, 2.
Very good. 0, 2. So that is your domain. It's just the coordinates that you started with, your input. Okay? All right, give people a minute to write. All right, range is going to be your output. Which one do you think is the output? The prime one. Okay? So that's what you ended up with. So your range is your output. So A prime, what are the coordinates of it?
1, -2.
Very good. B prime?
3.
It is 3 and 2. 3, 2. Yep, over 3, up 2. And then C prime? 1, 2, 3, 4, 5.
1, -1.
-1. 5, comma, -1. Okay. So domain is your pre-image and the range is your image. Okay. All right. Number 3, let a dilation be defined by a scale factor S and a center of dilation XY. Each of the options below represents a dilation of a polygon according to the given values of S, X, and Y. Which of the following dilations will produce an image congruent to its pre-image? All right, so what's something important in that? Congruent, we need them to be congruent. And what is this S standing for? What's the S stand for? Scale factor, circle that. Scale factor is your S, okay? What do we normally have to do with the scale factor? What do we have to do with it? Multiply it, okay? We have to multiply it. If you multiply something by 0, what happens? You just get 0. So they're not going to be congruent, all right? Because you're not going to get the same thing. For instance, if I take 8 and I multiply it by 0, do I get 8? No, I get 0. So that did not give me 8, okay? What if I multiply something by 1? You get the same number. So would they end up being congruent? Yeah, I'd get the same thing. So that would make them congruent. Congruent means they're going to be the same, okay? Uh-huh.
What is A not right? Is 0 would be 0.
So let's say that I have a triangle at 0, 1, 1, 0, and -1, 0. Okay? And I want to take this triangle and dilate it by, it says, a scale factor of 0 centered at 0, 0. So here's my center of dilation, and my scale factor is 0. That would mean I would multiply all these points by 0, which would give me 0, 0, 0, 0, 0, 0, which would not give me a congruent triangle. Okay? All right, what about E and F? What happens with those? What would I do with E and F? Multiply by 2. Would I get congruent figures? No. What happens when you multiply something by 2? It doubles, it gets bigger, okay? So your answers are C and D on that one, C and D. All right, flip it over. Number 4, Josiah draws circle E center to the origin with EF measuring 10 units as shown below. Josiah rotates EF 90 degrees counterclockwise about the origin to form EG. Which statement is true? Okay, somebody tell me something we know. This is a weird question. What's something we know? Hey, there's a circle. Okay, what else do we see?
90 degrees counterclockwise.
What are we going to do?
Rotate 90 degrees counterclockwise.
Okay, what are we rotating? The circle?
The radius.
We're rotating EF. So if you have a highlighter or a colored pencil or pen, you might want to highlight that. So we're rotating EF. How are we rotating it? Okay, which way would counterclockwise take it? Up or take it down counterclockwise? It would take it up. So draw your arrow, please. Draw your arrow. If you needed to, on the test, you could use patty paper with this one. You would do this. And you would turn my paper one time to the left, okay? And it ends up right there, okay? Another way to think about it is a 90-degree angle is a right angle. So we gotta have a right angle, okay? What does it say it forms when we do that? What is it forming? E, G. Do you see a G on there?
No.
So let's write it right there. Let's write G. Okay? So EG is now this red line I have going straight up. Okay? Questions? All right. Which statement is true? EF and EG are congruent. What do we think? Yes. E to F was how long? 10 units. How long is E to G? 10 units. So they are congruent. All right. Angle FEG. Let's make sure we're following this correctly. F to E to G. Is that 90 degrees? So the answer is A. Okay? Answer is A. All right, number 5. If the triangle below is reflected over the x-axis and dilated by a scale factor of 3, centered at the origin, what is the length of the new A to C? Okay, what is the length of the new A to C? All right, so if you reflect it over the x-axis, is that going to change how long it is from A to C? No, it's not. So you can even just ignore that. That is not going to affect how long A to C is when you reflect it over the x. What about when you dilate it by a scale factor of 3? That's going to change it. That's going to multiply it by 3, okay? All right, let's figure out what the coordinates of A are. A is at what? 2, 6. What is C at? -4, 0, okay? How can I find out how long it is from here to here? The distance formula. Hence why we had our warm-up today. So square root, I label this x, y, x, y. All right, so somebody who has an answer today, what do I put in the first parentheses?
2 plus 8.
Wait, where'd you get 8 from?
Oh no, I put B. I put the B.
Oh, okay. So, all right. So you can put 2 minus -4, or you can do what Allion said and turn those into. What's a minus and negative turn into?
Positive.
A plus. So you can do it that way too. Either way's fine with me. Then there's always a square there, always a square, and then always a plus. And then which 2 things go in the second parenthesis?
The Y.
The y's. 6 minus 0 squared. Okay? All right. So I'm going to type that whole thing in my calculator. Please do it with me. Go ahead and type that whole thing in your calculator. Square root. Parentheses 2 minus -4 squared plus 6 minus 0 squared. Type it in, please. Second square root. Oh, in your calculator? Oh, if you have a TI-83, you have to put 2 parentheses right here, or it will give you a different answer. So if you have an 83, a black one, you have to put 2 parentheses. You just hit the parentheses button twice on your calculator. So you do square root, and then you have to do another parentheses. 2 minus -4 parentheses squared plus 6 minus 0 parentheses squared. Okay? Got that typed in? All right, what are y'all getting?
4.8 now. Oh my God.
You have to use parentheses. You gotta use the parentheses button.
Oh,
Okay. All right. Anybody need help with their calculator? Okay. I get 8 yeah, what does it round to? 8.5. Okay. Is that my final answer? No, it's not my final answer. So look. Yeah, we found A, we found C, we found how long this was. It was 8.5. Yep, this is 8.5, but they said to dilate it by a scale factor of 3. So we have to multiply that by 3. Okay, times 3, 25.5. Right, 25.5. All right, number 6, Elizabeth drew a pentagon and line PQ on a coordinate grid as shown below. In her drawing, line PQ is located at x equals 5. If Elizabeth reflects the pentagon over line PQ, what will be the range of the reflected image of point R? Okay, one thing that is important is you are doing what? What are you doing with this line? You're reflecting over that line. So let's see, let's circle that word. You're reflecting the pentagon over that line. And then what's another key word in this one? Point R, that's important. What else is important? The range. Remember, range is your output. Basically, it's your answer, okay? What will point R become when you reflect it, okay? Another way to say it is we need to find R prime. We need to find R prime. Okay, so R is at 2.2, comma 4.3. When you reflect it over, let's count how many spaces this was. This was 2 spaces and, well, some more, right? We don't know exactly yet. We can calculate it, but for now, we'll say it's 2 and some more. Do y'all agree with that? Okay, so we need to go 2 and some more. So we're going to be somewhere in there. Would the height of it change at all? No. So what was your Y value? 4.3. So we know the Y value is going to be 4.3. That's not going to change at all. It's going to be 4.3, okay? Okay, it does get a little tricky, but if you need to, this was 2.2. So how far into this box was it? It was 0.2. Well, how much space would be on this side? Draw it on the board. So look, you have this point right here at 2.2. So this distance is 0.2. How much would this distance be? Point what? What's 0.2 plus 0.8? What do you get when you add those together? You get one whole box. Okay, so if this is 0.2, then this is 0.8. So we need to go 1, 2, and then 0.8. So what would that put me at? 7.8. Okay, so that's your answer. 7.8, comma 4.3. Okay, that one's hard. That's a tricky one. All right, flip it over. All right, on a coordinate plane, PQ is translated 3 units up and 3 units to the right to create P prime, Q prime. Line P is drawn through P and P prime, and line Q is drawn through Q and Q prime. Which statements about line P and Q is true? All right, if you look at the graph, have they given you anything to work with? No, absolutely nothing, okay? Have they given you any points to plot? Have they given you any points to plot? Yeah. Yeah, but that's the translation. That's not a point. Have they given you a point like 5, comma 2? No, okay. Do you think you can make up your own and try it? Yeah, let's make up our own and experiment with it. So, where do you want P to be at? Where do you want P to be at? 2, 2. Okay, so there is P at 2, 2. All right, 2, 2. Where do you want Q to be at? 3. All right, so we got 2, 2, and 3, 4. So P is at 2, 2, and Q is at 3, 4. Okay. All right, so we picked 2 points to experiment with. On the coordinate plane, PQ is translated 3 units right and 3 units up and 3 units to the right to create P prime, Q prime. So what do we need to do with each of these points? 3 up and 3 right. Okay, so I'll start at P, up 3, right 3. So that puts me at P prime. And then I need to do the same thing with Q. I need to go up 3 and over 3. So that's Q prime. Wait, I did something wrong. Up 3, right 3. That's P prime. And Q up 3, right 3. Okay, let's keep reading. So we did 3 units to the up and 3 units to the right. So we did that. So check, we did that part of the problem. It says line P is drawn through P and P prime. So where should we draw line P? From what to what? P to P prime. All right, so let me get a different color. P to P prime, that's line P. And then we need to draw a line Q from Q to Q prime. Okay, so that's line Q. All right, which statement about the lines P and Q is true? A says lines P and Q are parallel. Are my blue lines parallel?
Yeah.
So the answer is A. The answer is A. Okay. All right, number 8, segment A prime, B prime is formed by rotating AB about the origin. Which statement is not true? Okay, have they drawn the picture for us this time? Yes, thank goodness, right? All right, so let's look at A. Quadrilateral A prime, B prime is a trapezoid. We need to connect all these points. So get your pencil or your pen. We're going from A to A prime. And then, yep. So what is it making? It's triangle. Is it a trapezoid? No. Oh, wait. So what did the question ask?
Which one's not?
Not true. So the answer would be A. Okay. This is triangle BOB prime is isosceles. What do you think they mean by the O? The origin. So if you drew that from B to the origin to B prime, why is that an isosceles triangle? 2 sides are the same. This one is the same as that one. Okay? All right, number 9. Triangle ABC is mapped onto triangle A prime, B prime, C prime by a translation. Which statement is not true? All right, once again, if you look at the graph, have they given you anything to work with? So what do you need to do? Make a triangle somewhere. Okay, make a triangle somewhere. I'm going to do it over here. And label them A, B, C. A, B, C. You can make your triangle anywhere you want. You can make your triangle anywhere you want. What do they want you to do with your triangle? Translate it. What does that mean you have to do? Slide it. All you're allowed to do is slide it. Left, right, up, or down. What do you want to do?
Right.
To the all right, so I'm just gonna move it to the right. All right, so this is A prime, B prime, C prime. So I moved each point 1, 2, 3, 4, 5, 6. I moved each point right 6 is what I did. You can do whatever you want as long as you are consistent. So go ahead and draw your new triangle. Move it over. All right, and it says which statement is not true? What do I need to do to test this? A prime. What do I need to do right here? Draw a line from what? A to A prime. So it's hard to see, but there's my red line, A to A prime. And I need to draw a line to B to B prime.
That's true.
All right, what's this symbol?
Parallel.
Parallel. Are my red lines parallel? Yes, so that one is true. Okay? All right, what about for this next one? I need to draw a line from A to B prime. I'll use my highlighter for that. A to B prime. And I need to draw a line from A prime to B. Shoot. There we go. I screwed that up. But are they parallel? What did they do? They crossed. Okay, so your answer is B. Your answer is B. Okay. All right, last one. In the figure below, triangle OPN is the reflected image of triangle P or MPN. So as soon as I read something like that, I go ahead and circle it. So I know that I have a reflection. Okay? Go ahead and circle my keyword. Okay? All right. Anne states that reflections preserve side lengths. Is that true?
Yeah.
When you reflect something, does it preserve side lengths? Yes. Okay? Therefore, the triangles are congruent. So she's saying this side is the same as this side, this one's the same as this one, and these they share. So are the triangles congruent?
Yeah.
Yes, by what? Side, side, side. So this is true. All of that is true. Okay? All of that is true. What about Tim? He states that reflections preserve angle measures. Do the angles stay the same? Yes, that is true. That part is true. Does that make the triangles congruent?
No.
Just because you preserved angle measures? No, because that would be angle, angle, angle. Does that work? No. Okay, so who is correct? Only Anne. Only Anne.
Boy.